Here's the helper video for the Lesson 1.3 Student Activity Packet. This lesson reviews functions and function notation and how to use function notation. You can skip the introduction. The Learn It is the textbook part that reviews all of the information that you need. In mathematics, a function is a relationship between two quantities. For example, if one quantity is 2 and another quantity is 4, there's a relationship between those two numbers. Specifically, the number 4 is twice the number 2. When you express a mathematical relationship using symbols, you're giving a function. Highlighted in yellow is the reminder about function notation. It's a way to express how the function transforms an input into an output, such as f of x equals x plus 5. That equation, f of x equals x plus 5, is a way to write in symbols a relationship between some number that we're calling x and some other number that we're calling f of x. This function notation is useful because it allows us to substitute any value we want for one number, that is, in place of the x, and then evaluate what f of x would be. For instance, when x is 1, f of x would be 6. When x is 7, f of x is 12. This notation says that the function f is always 5 more than whatever number is being used for x. Here's an example. Johnny triples his money by investing and then pays $2 in taxes. Write this relationship using function notation. And you see that shown out step by step with the final result highlighted in yellow. F of x equals 3 times x minus 2. That equation matches that sentence that we were given about Johnny. Now comes the practice it, where you're actually typing some answers down. Question 1. Model the function f, which operates on the variable x by adding 2 and then doubling the quantity. Type f of x equals, and then translate the mathematical operations in the sentence into symbols. First is x add 2, and then you double that. So in parentheses, x plus 2, and then double it, which means to times by 2. You might put the 2 in front of the parentheses to make that look good. Next, number 2. Jeremiah makes $15 an hour working part-time at the restaurant. He pays 11% in taxes on his earnings. Use the variable h to be his hours worked, and model his weekly after-tax wages as a function w of h. Start by typing w of h equals. What you've typed so far is, what are his weekly wages based upon the hours that he's worked? Now let's translate what the sentence said. He makes $15 an hour for h hours. That's 15 times h. 15 times h is his wage before the taxes are applied. If he pays 11% in taxes, then he gets to keep the other 89% of the paycheck. So one way to show that would be to put the 15h in parentheses, and then in front of it, put 0.89 times that 15h. This mathematical expression shows that his weekly after-tax wage, which is based on the hours worked, is 89% of 15 times h. Next, number 3. Sarah goes to the grocery store and buys 4 packs of gum. Sales tax in Connecticut is 6.35%. Use the variable g to be the price of 1 pack of gum, and write a function p of g to model the scenario. Start by typing p of g equals. Let's translate what we read in the sentence into math symbols. Sarah buys 4 packs of gum, and we're using the letter g to represent the price of each pack. So 4 times G is the cost of the 4 packs of gum. But she has to pay the sticker price of the gum and then pay extra called sales tax. So one way to show that is to put the 4G in parentheses and then in front account for the fact that she pays for the gum but then also pays an extra 6.35% for tax. And that can be shown by in front of the 4G putting 1.0635. Think about it like this. That decimal I just typed is like 106.35%. She's paying 106% of the price of the gum because she pays for the gum and she also pays 6.35% for tax. Next, number 4. Janet rents a booth at the farmer's market that costs $150 a day. She sells jars of honey for $8 each. At the end of the day, she splits all of the money she brings home with her mom. Use the letter J to be the number of jars of honey sold, and write a function f of j to represent the money Janet makes each day. Start by typing f of j. I'm not quite sure why the letter F is chosen instead of some other letter that kind of fits the story a bit better, but what the f of j means is the amount of money based on the number of jars. Let's take all of the information in the story and translate it into algebra symbols that show the relationships. Each jar that she sells is $8, and she sells J jars. So 8 times J represents the money that she's made from selling the jars. But it cost Janet $150 to rent the booth. So from that money she's earned, she needs to subtract $150. Finally, she splits half of the money with her mom. So one way to show that is to put that quantity in parentheses and then in front of it show 1/2. That can be done as a fraction or the decimal 0.5. This equation, which is written in function notation, models how much money Janet takes home each day. Scrolling down, we get to another Learn It section. Again, this is textbook information. It gives you vocabulary and often models how to go about doing a problem. So here we have this question about Maritza tutoring at the community center. And then step by step, it shows how to do this process. Really, it's taking those equations, like the ones we just made, and substituting a specific value in place of the variable, and then performing the calculations to get the answer. Next is a reminder about domain and range, which you would have learned about in your algebra class. Domain and range describe the limits of a function. A function, remember, is a relationship between two quantities. Sometimes there are limitations upon the values of the variables in the quantities, and those limitations are expressed using domain and range. Here's an example showing specifically how that's done. Scrolling ahead, the next Practice It section. Taylor makes $13 per hour at the grocery store. She always works between 10 to 15 hours per week to leave time for homework. Her gross wages can be modeled as W of H equals 13H, where the letter H is representing the number of hours worked. The letter W is probably standing for wages or maybe weekly wages. Question A, how much will her gross wages be if she works 12 hours this week? We're going to use the function notation given in the story, and in place of the letter H, fill in the specific value, 12. Remember, the letter H was representing how many hours does she work, and so if she works 12 hours, you replace H with 12. The same on the right side of the equals. Replace the H with 12. Take a calculator and figure out 13 times 12. 156. Because this is a story problem, it's always good to label what the 156 is. Remember, this was what were her gross wages, so this is an amount of money. I need a dollar sign in front of the 156. The domain of a function is a description of what values you can have for the independent variable. The independent variable is the one that's in the parentheses of the function notation. In this case, it's the h. That's the thing that Taylor controls. She sort of has control over how many hours she can work. The other variable, the w, is the dependent variable because that depends on how many hours she works. If she works only a few hours, her wages is a small amount. If she works more hours, her wages will be a larger amount. The wages depends on the hours worked. So domain, a description of the independent variable, the h. What values can h be? You type h and then mathematically describe the possible values. It says in the story she works between 10 and 15 hours. So one way to show that is to say that her hours that she works has to be greater than or equal to 10, but her hours worked must be less than or equal to 15. Now in algebra class, you learned a symbol for greater than or equal, which is the greater than symbol with a single line under it. Similarly, less than or equal, there's a symbol for that. And a Chromebook does have those symbols. They're just not really easy to insert. So a fast way to type greater than or equal or less than or equal is the way that I did. Alternatively, there might even be a better way to type this, and that is to say that h is in between 10 and 15 hours. And that would look like this. This statement is the same as the first one that I typed. Question C, what is the range of the function? A range is a description of the values that the dependent variable can take. The dependent variable is the w, her wages. What are her possible wages? Is there a minimum possible wage in the week? Is there a maximum possible wage? The range often will depend upon what we have said for the domain. The smallest number that we're going to use for h is 10. What are her wages if she works 10 hours? So 13 times 10, that's $130. But at a maximum, she works 15 hours in the week. What are her wages if she works 15 hours? That's $195. Now that we know those limitations, we can write out the range. I'm going to type it like this. 130 is less than or equal to W of H, which is less than or equal to 195. I'm showing in symbols that her wages have to be in between $130 and $195. Now over to number 2. Susan earns 0.5% interest annually on her savings account. She can model her savings account balance after earning the interest for a year using the function f of x equals x plus 0.005 times x, or f of x equals 1.005x. You might recognize this as similar to a previous question in this video. Question A, what will be her account balance after a year if she started with $30,000 in her account? F of $30,000. I'm going to use the second version of the function given. It just looks faster to me. So 1.005 times 30,000. Typed it in the calculator to get the answer. $30,150. Question B, what is the domain of the function? Domain is a description of the values that the independent variable can have. That's the variable in the parentheses, in this case x. X is her savings account balance. So what are possible values that somebody could have in a savings account? Well, I suppose they could have $0. Or they could have more than $0. So let's describe that with symbols. X could be greater than or equal to 0. At a bank, you're not typically allowed to have a negative amount of money in your savings account. Now question C. What is the range of the function? This is a description of the values that the dependent variable can have. In this case, it's the f. F is also her account balance after she's earned interest. What's the smallest her account balance could be? If she has $0 in the account, then she's not going to earn any interest on that, and she's still going to have $0 in the account. So a lot like question B, this minimum value is again a 0. But this time we're describing f of x. And there's the range. Question 3. Joan has an employee discount of 15% off at Stuff Mart. She needs to buy 4 packages of hot dogs, 3 packages of buns. A pack of hot dogs costs that, and the buns cost that amount of money. Fancy buns cost that. If B is the cost of a package of buns, she can model her purchase as, and then you see this pretty long expression. Question A. What would her total purchase price be if buns cost $1.50? If buns are $1.50, then in place of the variable B, substitute $1.50. Every time you see a B, put in $1.50. So as we're doing this and filling that in, this is what the function starts to look like. Then take a calculator and type that in. And the result is 12.32. This is a cost, so a dollar sign is appropriate. Question B, what is the domain? What are the values that the variable B can have? Well, what's the variable B representing? The cost of the buns. Cheap buns are 50 cents. Fancy buns are $4.50. She actually found some buns that were $1.50, a price that's in between the cheap and fancy. So it looks like the cost of the buns could be anything between 50 cents and $4.50. That can be shown like this. Question C. What is the range of the function? Describe the possible values for the dependent variable, the variable C, the overall cost. This is going to depend upon whether she buys the cheap buns or the expensive buns. We need to figure out the cost if she uses the cheap buns. $9.77. But we also need to know what is the cost if she uses the fancy buns. $19.97. Now that we know the minimum cost and the maximum possible cost, we can describe the range. One way to do that is to go $9.77 is less than or equal to C of B, which is less than or equal to $19.97. Question 4. The function f operates on the variable x by tripling it, then adding 5, and then doubling that quantity again. This can be modeled as shown. What would be f of 22? Replace the x with 22. $142. What would be f of negative 22? Negative 122. Question C, what is the domain? How can we describe the numbers that can be used for x? In this story, there's no mention anywhere of any limitations on what can be used for x. It appears like it can just be some random number that we want. Seems like it can be negative, it could be a 0, it could be positive or whatever. So x can be any real number. In your algebra class, your teacher might have had you write it like this, or asked you to say that the domain is all real numbers. There's different ways of showing this. Question D, what is the range? The range is a description of the dependent variable. Range is going to depend upon what numbers you have for your domain. The domain can be any number, any negative number, any positive number, super large numbers. It can be any number whatsoever. So it seems like if the math operations involve multiplying a number by 3, adding 5, doubling, that if you're allowed to start with any number you want, that the result could be any number as well. F of x is any real number. This concludes the video.